Continue on Chapter 8, Differentiation. 8.3, Differentiation of exponential and logarithmic functions. These are the learning outcomes for this lesson. Differentiation of exponential functions. We have two rules. First one, differentiate e power of x equal to e power of x. And second one, differentiate e power of fx equal to e power of fx times f prime x. Example, differentiate each of the following with respect to x. First, y equal to e power of 3x plus 4. Differentiate y, we get dy dx. Differentiate e, we have e power of 3x plus 4 itself. And differentiate power of e, 3x plus 4, differentiate, we get 3. So dy dx equal to 3e power of 3x plus 4. Next example, y equal to e power of negative 3 over x. X cannot be denominator, so simplify this function, we get y equal to e power of negative 3x negative 1. And differentiate y, we get dy dx equal to negative 3 e negative 3x power of negative 1. And differentiate power of e, we have negative 3 times negative 1 x power of negative 2. Simplify 3e negative 3 over x times 1 over x square. So simplify 3 positive x square e power of 3 over x. See y equal to x times ex. In this case, we have 2x. X times ex, so we need to use product rule where u is x and v is e power of x. U equal to x, differentiate u, we get 1. And v equal to ex, differentiate v, we have ex. Differentiate y equal to x times e power of x. Differentiate y, we have dy dx. Product rules, we have v u prime plus u v prime. So substitute formula, v is e power of x, u prime is 1, plus u equal to x, and v prime e power of x. Simplify, factorize e, we have 1 plus x times ex. dy equal to 3x plus 2 over e power of x. In this case, we have quotient rule, u over v. So u equal to 3x plus 2, u prime is equal to 3, v equal to e power of x, v prime, differentiate e power of x, we have e power of x. Then differentiate using quotient rule, differentiate y, we have dy dx, v u prime minus u v prime over v square. So v is e power of x, u prime equal to 3 minus u, 3x plus 2, v prime is e power of x, divided by v square, ex square. Simplify, factorize e, we have 3 minus 3x minus 2 times e power of x, ex square. Simplify, 3 minus 2, 1, minus 3x, and then ex cancel with ex. We have over ex. So dy dx equal to 1 minus 3x over ex. And this one, we can simplify to use product rules. From y equal to 3x plus 2 divided by ex, simplify, we get y equal to 3x plus 2 times e negative x. So using product rules, this is u and v. So u equal to 3x plus 2, u prime equal to 3, v equal to e negative x, v prime, differentiate e negative x, we have e negative x, and then differentiate negative x, negative 1. Then differentiate function, differentiate y, we have dy dx. Using product rules, v u prime plus u 3x plus 2, v prime is negative e negative x. Simplify, factorize e power of negative x, we have 3 minus 3x minus 2. Negative 1 times 3x is negative 3x, and negative 1 times 2 is negative 2. Then e power of negative x. Simplify, 3 minus 2 is 1 minus 3x over e power of x. So whichever method we use doesn't matter. We still get the same answer. Next example, y equal to e power of negative 4x squared plus 12x. Differentiate y, we get dy dx equal to, differentiate e, we have e itself, e power of negative 4x squared plus 12x. And then differentiate power of e, negative 4, differentiate x squared, we get 2x plus differentiate 12x, we get 12. Simplify answer, negative 8x plus 12 times e negative 4x squared plus 12x. We can stop here or factorize 4, 3 minus 2x times e negative power of negative 4x squared plus 12x. Okay, the function e here must be the same as question. Last example, y equal to 1 minus ex power of 5. So in this case, you can use chain rule, let u equal to 1 minus e power of x, or power rule. Differentiate y, we get dy dx, and then differentiate y minus e power of x power of 5, so power to the front, 1 minus e power of x, 5 minus 1 is 4, and then differentiate 1 minus e power of x is negative e power of x. Simplify, we get minus 5 e power of x, 1 minus e power of x power of 4. These are your exercises. Please submit the exercises at the end of lecture.